Welcome to today's webinar, Riverbed and Big Switch, AWS VPC Performing Monitoring and Visibility. My name is Sharon Fitzpatrick, and I'll be your host for today's webinar. Our speakers are Alfred Jones and Joe McCarthy from Riverbed, and Bala Ramachandran and Jagdish Akula from Big Switch. As we go through the presentation, feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this in a rebroadcast or on demand, please let us know if you have any questions. Just email us at info@bigswitch.com. We've also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. Our agenda today features SteelCentral AppResponse Cloud, public cloud monitoring, the joint Big Mon and Steel AppResponse AWS solution, 2 demo test drives, and Q&A. As you can see, we have a full agenda for today, so let's get started. Our first speaker is Alfred Jones, Director, Product Management, Riverbed Technologies. Alfred, it's all yours.
Thank you, Sharon. Good morning or good afternoon, everybody. It's a pleasure to be here. I wanted to take a few minutes and tell you about a AppResponse Cloud solution that we've invested in heavily in the past year and a half, and how it's relevant to the broader cloud adoption that we're seeing and that we're working with Big Switch on. So at a very high level, AppResponse is a packet analysis product line here at Riverbed. It's broadly aimed at IT operations in most classic enterprise organizations. Inside of IT operations, we tend to talk mostly to network operations, network engineering, design, architecture. That's the enclave inside of operations that we target. Our typical users are very advanced performance/network engineers. That's kind of our sweet spot. There are dependencies, even though these could be our core users. These users, in fact, enable and drive other workflows in other boxes in this typical org chart. For example, DevOps and application operations. There's obviously a tie-in with the help desk. So these users actually sit at the hub of a lot of information that flows in and out of IT operations. To get a little bit deeper into the types of users and the types of information they expect to get from AppResponse, these are some examples of typical questions that AppResponse customers and users ask. And these are all tailored towards performance and activity in the network and slicing and dicing. I've put up a few examples here. The first one is asking if an existing server or an application is actually slow. It's very common for our users to be on the triage side of advanced trouble tickets. They're usually like level 3 or level 4 troubleshooting. And somebody has reported some level of slowness that's gotten triaged by help desk, and it comes through. And one of the first questions, is it actually slow? If it is, by how much? And what is the general trend for performance for whatever that resource is? It could be a server or an application or service of some sort. And what is its range of performance that it should normally be at? There are related questions, and these tend to sort of join with each other in a drill down fashion. You can start with one of these and migrate to another question. You can start with any one of these and go to others. It's also common for a lot of our users to generally have this "what did the network do" type of question. And it's a multi-dimensional question. It's not a simple answer. Networks play a complex role in delivering services, and there's a lot of interplay between various components that make up your network. So what did the network do? Did it, for example, affect a certain aspect of the service being delivered? If it was, what was that aspect? When did it start? When it finished? So these are the typical questions that our customers and users ask, just to give you a sense of the type of product AppResponse is. Apart from just performance, AppResponse also focuses a lot on giving you resource usage information. Right? Network is a vast and distributed complex resource. It's very expensive depending on how you set it up. Who is using the resource? When are they using it? What are they using it for? And these resources could be human beings doing stuff and creating activity in the network versus automated resources like servers and infrastructure like load balancers. And what are they doing and when do they pick up? It is fairly common for AppResponse users to use network activity as a a piece of forensic information. For example, seeing a traffic that was recognized as backup somewhere in the data center, and then correlating that with front-end performance, and then to realize, oh, wait a second, this particular tier in this multi-tier application was actually busy doing backup, and its processing delay sort of went up. And this is all information that AppResponse picks up by instrumenting the network itself. So this is a summary of the space in which AppResponse plays. We think of it as the network performance management sort of market space. Our buyers, like I said, tend to be fairly advanced operational performance and architects and engineers. Those are some of the core use cases, right? The application performance and its profile, usage, and trending from a network perspective. What, if anything, did the network do to the business critical services that our customers monitor? And also, apart from just measuring app performance, and there are several ways to do that, we can also measure app performance in a bespoke fashion. There's a general way to do it, where you kind of sit at layer 4 and watch TCP activity and pull out intelligent information. But we also have bespoke analysis for web applications, which is pretty much a vast majority of the applications that end users consume. Citrix is a huge application delivery infrastructure that customers have invested in, voice and video, and database. So there are flavors of app performance analysis this one product embodies. You can break that application response time into sources. How much of that is coming from the network? If it's coming from the network, exactly what metrics is it contributing? And launch into sort of troubleshooting. The usage piece, measure it by application users and all the other dimensions that you have in mind when you're looking at a particular problem. And of course, a lot of this metadata is stored for long-term storage. You can go back in time, a month, a few months, to either do trending or capacity planning, or in fact to pick out patterns in how this activity has changed. So this is the mission statement for the product. We usually like to put this up because it encapsulates the core of what the product does. Its goal is to make network operations / engineering life easier. That's really the goal. The product does it by instrumenting the network. Primary input is packets coming off the network. There are several ways to do that. The reason we spend so much time investing in this packet analysis because packets are actually very valuable for all kinds of forensic information. And there's a widespread belief, we call that packets don't lie. A lot of the customers I talk to sort of, subscribe to that theory. It's not a bad one to have in your back pocket. This is packaged as an appliance, so it's easy for customers to deploy. Talking about the product itself and some of its primary attributes, I mentioned it's an appliance. It's a passive data collection appliance, which means you stick it on the network. It doesn't actively participate or interfere in any way with ongoing activity, unlike active devices like routers and switches and load balancers. Packets stream into the appliance. The packets are analyzed across several dimensions in real time, and the packets are stored at the same time. The real-time analysis has a fair amount of intelligence that we've built up over the years for things at the general TCP and then the bespoke layers like web and multimedia and database and Citrix. The packet capture that we support in the appliance is very flexible. You can tune it to your particular needs because an appliance sitting in one location may have a different role in your forensic standpoint than maybe an appliance sitting in a branch. So there's a fair amount of flexibility there. And the capture can encompass all users, all applications, depending on how you tune it. In terms of the workflows themselves, you'll be drilling down into root cause analysis. A lot of it is real-time data, but you're actually going back in time to pick out the data and sort of seeing it in context. And of course, contextual access to packets. It's fairly common for the AppResponse power user to do a lot of slice and dice from the metadata, and then at some point say, I want to go and prove my conclusion, and I want to use packets for that. So, AppResponse, give me the packets for that. So that's one fairly common end step in a lot of the analysis workflows that we support. So this is a poll that we were hoping to get some information from you. This presentation obviously is focused on performance visibility in the cloud. We wanted to get a sense of where most of you are in this particular initiative. I'm sure that I see this in all of the customers I talk to. So I think this is where you take the time and maybe send in your answers.
While we're waiting for that, I'd love to know where you guys think this is going to end up. So, Paula, do you have any thoughts?
Yeah, I believe that, we are seeing increasing public cloud adoption, and, it started off with just dev test, but now increasingly production services are coming up in cloud. So I would think that, there would be some amount of that.
How about you, Alfred? What's your thoughts? And then I'll share the results.
Public cloud adoption is a dominant theme in pretty much every customer conversation I have. The maturity of the adoption, the degree to which people have actually committed to it tends to be different, but the level of visibility and investment is there in every customer I talk to.
Well, you're both right. 67% say production services are up and running. So it's really 2/3 of our audience today. So thank you, everyone. And I'm going to close the poll and give it back to you, Alfred.
The next poll question was to get a little bit of sense of the flavor of adoption that you have. If you have performance visibility, I understand with the assumption that that's something you care about. To what extent do you have any kind of visibility into the resources that have been put into the cloud in your organizations? If you could give us a little bit of a flavor here, that would be helpful.
Curious, Alfred, let me just ask you, because I know we're kind of trying to keep things moving. Where do you think this is going to come up?
I think it's going to be between the second and third options. There are some customers who've got stuff in place because they've sort of hit the adoption curve early. But a majority of the customers are very actively evaluating options before they make a big sort of investment decision. This kind of visibility doesn't come cheap, so I would expect to be somewhere between the second and third options.
Well, I'm going to close the poll and share the results, and you are incorrect. It's really have nothing yet thinking about it. So we have an audience that I think is in the curiosity mode, and I think today's topic will give us a good way to get people a little bit of information and next steps. So I've closed it, I'm going to hide it, and back to you.
Thank you. That's one case where I'm happy to be wrong. That's a good answer for a product manager to hear.
Yes, it is.
So at a very high level, this is an appliance. I'm giving you a picture of the deployment modes. The one of interest today is the one on the far right. That's the project that we've been working on for a while. That actually hooks into our relationship with Big Switch. This is an AppResponse Cloud deployed in public cloud. One of the options for instrumenting the device is going to be through BMF, which you're going to hear about. So we have different options, hardware, virtual, and the cloud version appliances, and then they each have their own respective sources of packets. Let's jump into the snapshots. Yeah, so this is a snapshot of what the AppResponse UI looks like. We in fact have a short demo coming up. So instead of me spending time with these slides, I think I'll give you guys time to actually see the demo.
Thank you so much, Alfred. It was great to learn some new information and also to kind of hear where the audience was in their life cycle planning for cloud. Before I turn it over to our next speaker, Bala Ramachandran, I want to actually go through and launch another poll so that we can kind of just get a sense for what your plan is for cloud. So I'm going to launch that. And if you can share with us on that, Bala, where do you think this is going to go?
I think we're hearing a lot about hybrid cloud. I mean, you will see, some results that we got from analysts and all that. So I would think that, more people are looking at hybrid cloud and maybe even multiple clouds.
Well, you know what? You're right. Because when I look at sharing the poll results, we definitely see that 60% of the audience is definitely looking at hybrid cloud. And so I think it's really interesting when we think that it's really not just private or single cloud, it's really private plus public or multiple clouds. I'm going to turn it over to you to go through your presentation.
All right, thank you, Sharon, and thank you, Alfred. It was great to learn about how Riverbed AppResponse for AWS provides application performance monitoring for AWS workloads. Now, we will go through how the joint solution of BigMon Fabric with Riverbed AppResponse enables pervasive visibility for AWS applications. and how it simplifies the operational experience for application analytics in a manner that is consistent with the on-prem solution. Now, we saw the poll results, and it's amazing that the results that we're seeing with our audience is closely matching what we see here. We do see an increasing adoption of hybrid cloud by organizations, and this has been corroborated through analyst reports and surveys. Now, the IDC survey in the left indicates 51% interest in private plus public, that is hybrid cloud, and 21% for multiple public clouds. And in terms of the projected hybrid cloud spend, the results on the right, 60% is expected to be with private or enterprise cloud and 40% for public cloud. So the move to hybrid cloud is really part of a broader IT transformation initiative to get speed, agility, and visibility. And so it is important to simplify both the app deployment as well as the monitoring workflows and make them consistent across both the on-prem deployments as well as cloud infrastructure. So today we see a lot of siloed solutions that exist in many hybrid cloud deployments. So what we are striving to get is that consistency. So let's, in terms of our solution for BigMon and Riverbed, let's first look at the on-prem enterprise cloud monitoring solution. So on the left-hand side here, you have the data center production network that is connected to a logical scale-out fabric in the center, which is really a network packet broker managed by a single pane of glass SDN controller. Now, the tools on the right-hand side are connected to the other side of the logical fabric. Now, the copy of traffic that is sent from the production network via tap or span are processed and sent to one or more tools on the right-hand side. And so that's essentially what this is doing. Now, to achieve this, the fabric really consists of one or more white box, bright box, Ethernet switches managed by a central SDN controller, where the user defines the rules to filter, aggregate, replicate, load balance traffic to the appropriate tools in the tool form. Now, if you think about it, the management complexity is bounded here to a single logical switch, irrespective of the number of switches in the fabric. So that is really the big operational saving that we get with this architecture. And also, advanced packet functions like deduplication, header stripping, net flow generation are all done using a service node, which is a DPDK-enabled x86 appliance. And again, the important thing to note is it is connected to the fabric and managed as part of the same controller. So there is no separate interface for this appliance. And the BigMon capabilities can be augmented to provide packet capture using recorder nodes and advanced analytics using analytics node. So both of these, again, are x86 appliances and managed by the same BigMon controller. So in a way, all of these different elements of the fabric, the core central fabric, the service node, the analytics node, the recorder node, they are all integrated and can be leveraged to create this integrated workflow for deep network analytics and pervasive monitoring, all managed from the single pane of glass. So that is, the key idea or, the key value proposition of this BigMon Enterprise Cloud. And what we will see next is, how this exact architecture is applied to AWS monitoring. But before we see that, let's quickly understand the challenges in monitoring a public cloud like AWS. The cloud typically has multiple instances, which are placed in subnets. The subnets are in turn placed inside availability zones. Multiple levels of visibility is needed in this scenario. So you need inter-instance traffic visibility within a subnet, availability zone traffic visibility, external traffic visibility, VPN traffic visibility, and so on and so forth. So pervasive visibility is a requirement both for private and public clouds. So we get a complete picture of application performance. At the same time, operators who manage hybrid clouds do not want different approaches or workflows for operational and network analytics for each of their cloud platforms. So the key challenge for us to solve is to get this consistency while getting the pervasive packet or flow analytics across all the clouds. So we went over the on-prem architecture of Big Mon. Next, let's see how the joint Big Mon AppResponse solution for AWS has a very similar architecture to the on-prem version, leveraging a single pane of glass to monitor workloads in AWS. And I'll go through a high-level overview and then hand it over to Jagdish, who will actually go through a detailed demo of it. So how do we achieve pervasive visibility for performance monitoring across the different points that we talked about in an AWS VPC? An inter-instance, inter-availability zone, external. We create a separate VPC, which we call as monitoring VPC. This enables simplified and centralized monitoring of AWS workloads, and this is not done in a siloed manner. That is, the monitoring VPC is not restricted to monitoring a specific VPC or specific instances in the AWS cloud. Traffic from multiple instances or VPCs can be monitored by the same monitoring VPC and sent to the Riverbed AppResponse tool in the tool subnet. This is one of the key benefits of the monitoring VPC, as it hosts the single pane of glass Big Mon controller instance that can be used for configuration and visibility across multiple instances or VPCs. And as you can see, this is a very similar approach to the enterprise cloud monitoring that we discussed. So the multi-VPC visibility. Then once we have the monitoring VPC deployed, we will start automatically discovering the various entities, the VPCs, the instances, the subnets, etc. The user will now have the visibility on the UI to create policies to monitor one or more VPCs or instances and send the traffic to one or more Riverbed AppResponse tools. When a policy is created, what you see here is when a policy is created, an agent is automatically installed if it does not exist already, an agent at each of the instance. The agent's role is really to send the traffic over L2GRE to the CloudLight VX switch. Now, it is important to understand that the agent is installed automatically, and the user does not have to be involved in installing it at any point in time. Now, the rules for CloudLight VX is automatically created as a virtual switch in AWS, which will then trigger the traffic to be sent to the AppResponse tools via CloudLight VX. Again, this is consistent with the on-prem enterprise cloud approach for packet or flow visibility that you're used to. Now, what if the workload bandwidth has increased for the user? We will add more virtual switches for scaling, similar to how you do it in enterprise cloud monitoring, where you add more physical switches. So that's the elastic scaling that you get with this architecture. And once that is done, the replicated traffic is sent to the virtual switches, which are then sent to the tools based on policies. So all these green lines indicate the GRE encapsulated traffic, as that is the way traffic moves within AWS. Now, with this high-level overview of how Big Mon for AWS is used for monitoring instances in AWS in a way that is consistent with on-prem monitoring that we talked about earlier, now I'd like to turn it over to Jagdish for a detailed demo of the solution.
Great. Thank you so much, Bala. I'm really excited to see what the demo looks like.
Welcome to Big Monitoring Fabric Public Cloud and Riverbed AR11 Cloud Demo. Before we jump into the demo, let's take a look at our demo topology. On left, we have production VPC, which contains our production workloads. And on right, we have monitoring VPC, which gets created when Big Mon public cloud is deployed using CloudFormation template. As we can see, the monitoring VPC consists of two subnets. Big Mon subnet, where Big Mon controller and CloudLight VX virtual switch resides, and a tool subnet where tools such as AppResponse is deployed. Tool instance deployed in the tool subnet will automatically get discovered by the Big Mon controller. Now, to gain traffic visibility into a desired workload or VPC, a policy needs to be created. When a policy is created, controller will create a VPC peering between production VPC, where the workloads reside, and the monitoring VPC. Next, controller will check to see if CloudLight AX agents are installed on the workloads to be monitored. If not, the controller will automatically install the CloudLight AX agents. The controller then pushes the policy configuration to the CloudLight VX virtual switch, where packet forwarding decisions are made. Now let's log in to the Big Mon controller UI using the public IP address. From the landing page of the Big Mon controller UI, we get an overview of user account inventory, which Big Mon controller has pulled automatically. The inventory section provides a summary of Fabric, Big Tab policy, cloud, and security settings. Fabric subsection gives us information on number of virtual switches deployed. Big Tab subsection displays total number of policies that have been created and filter and delivery interfaces used. Similarly, the cloud subsection displays the number of VPCs, subnets, monitorable instance, tool instance from the user account. And finally, security section displays the number of users and groups created. To get detailed information of user account inventory, we navigate to the cloud page. Here, we can see that we have visibility into all the VPCs, subnets, monitorable instance, and tools in the user account, giving user centralized single pane of glass management. VPC inventory consists of all the VPCs within the account. For each VPC, we can see the VPC ID, SATA block used, subnet counts, and monitorable instance count. For monitoring VPC, tool count, controller, and virtual switch count is also displayed. If we drill down into one of the VPCs, we can see the workloads and their attributes like workload ID, image ID, and which subnet it resides on within VPC. Subnet table displays all the subnets within the user account. For each subnet, we can see the subnet SATA block, which VPC it belongs to, and monitorable instance on the subnet. If it is a tool subnet, total number of tool instance is also displayed. For Big Mon subnet, controller and total number of virtual switches is displayed. One can see all the workloads and their attributes for the entire account in the monitorable instance table here. This is similar to how it would be displayed on native AWS console. Tools table displays all the tool instances that reside on a centralized tool subnet. We can see that AppResponse, which was deployed in the tool subnet, got discovered by the controller, hence it is displayed here. Finally, agents table displays the total number of instances on which the CloudLight AX agent has been installed. This table also displays what state the agent is in, whether it is installed and running. Since AppResponse does not require an agent to be installed, the agent installed and started state are both crossed off. Now let's create a policy to monitor traffic from our production VPC and send it to AppResponse tool instance. We will give a name AR11 to the policy, append the desired rule to the policy. In our case, we will use any, so all traffic is forwarded to AppResponse. Next, we select the traffic feed. Here, user can select single or multiple VPC, or desired subnet, or individual workloads. In our case, we will select a VPC of interest, so that traffic from all the workloads is forwarded to AppResponse. Next, we select AppResponse tool instance where traffic is to be forwarded. And finally, we create a policy. Once policy has been created, the CloudLight AX agent will replicate traffic from workload and send it to CloudLight VX virtual switch over VPC peering. Optional filtering and additional packet modifications are then done on CloudLight VX virtual switch as per policy defined. CloudLight VX virtual switch then forwards the filtered packet towards the tool. Let's take a look at policy stats to validate that traffic is being forwarded from production workloads to AppResponse. As we can see, both filter and delivery interface stats are incrementing, which indicates that traffic is being received on the filter interface and forwarded towards tool on delivery interface. Going back to Cloud tab and scrolling down to Agents table, we can see that the Cloud Light AX agent has been installed and started automatically by the controller on the production workloads. Now let's log in to the AppResponse UI using public IP. We can see from the graphs here that traffic from the production VPC is now being received on the AppResponse. So what are some of the key takeaways from the demo? Simplified deployment of Big Mon public cloud using CloudFormation template, auto discovery of inventory in a user account like VPCs, subnets, workloads, and tools such as Riverbed's AppResponse, which gets deployed in tool subnet of Big Mon public cloud. And finally, simplified policy to forward traffic from production workloads, tools like AppResponse. More details of AppResponse in Joe's demo coming up next. Thank you for watching.
Thank you so much. At this point, I'm going to turn it over to our next presenter, which is Riverbed's tech evangelist, Joe McCarthy. Joe, it's all yours.
Okay, as you heard from Alfred, AppResponse provides full-stack application analysis, what we call packets to pages. This allows users to observe all network and application interactions as they traverse your network. AppResponse can be deployed as an on-prem device, virtual machine, or AWS cloud-ready solution, which is what we're demonstrating today by leveraging packets pulled from the Big Switch. So looking at the AppResponse dashboard, we provide a wealth of information at your fingertips. Here at the home screen gives you the view into all traffic, starting from a high-level view, and as you work your way through the dashboard, you can see more granular information. So let's go through the screen real quick. You can see we have throughput highlighted, so all the widgets following this will be looking at throughput. So we can see how things are working across the applications and how they are throughout your network. If I was to click on, say, round trip time, now I can identify what are the slowest applications running out there. So here we can see in this widget down below, we're looking at applications. So we can see HTTPS is the slowest application within our environment. And we get a before and after. So we're looking at HTTPS yesterday, which is the lighter of the colors. In the darker colors, you can see if there's any difference from today or yesterday. Now, one of the more powerful views within AppResponse is our response time composition chart. What that does, it tells you where is the slowdown happening. Is it the server, the application, the network? So now you know where to focus. So if we want to find out why HTTPS is reacting slowly, I can simply highlight it, go down to chart, and look at the response time composition chart. So now I can see where is the slowdown actually happening. We can see the red is more of the dominant color, and that happens to be server response time. So now I know where to focus my attention. I won't mess with the network folks because I know it's server based. That's how you can very quickly identify where to focus your attention and get your users back up to where they need to be. And as you can see, let me close this out. We use a tab format to quickly navigate through all this information. So here we're looking at applications. I can look at the top server IPs. Maybe you want to look at the client IPs, or even IP conversations. So very quickly you can navigate through a wealth of information within AppResponse. AppResponse also provides a tool called Insights here at the top ribbon. When I select it, you can see you can pick from TCP IP type traffic, web, UC, VoIP or video, database, and even look at very specific transactions. What it is, it's a very fast way to navigate using predefined views that AppResponse builds for you. So let's say you wanted to find out what the slowest page views are within your network. So from here I can go into transactions and simply select page views. So now I have a good sense of what's going on as far as page views are concerned within our network. Now this screen here where it says True Plot, what's unique about this view, and it's a differentiator for Riverbed, is each one of these dots represents an individual transaction. So what line graphs and bar graphs do is they take all this data and they assimilate it into one view where you don't see any of the outliers or any oddities that might be happening. Here you can see the very specific logins were being affected through the TradeFast application. Now it bubbles up the slowest transactions or the individual page views for this specific application. And here you can see where in the methods, so this is where, remember I was talking about, we go from packets to pages, since we download all the packets, we can see specific methods and we stitch that transaction together. So when a person logs in to the TradeFast application, we see each step they take and how much time each step does consume. And we can see that this method here, where they're downloading a logo.jpg file, it's taking, this is seconds, like 122 seconds to download this file. Very inefficient. So now what I can do as an awk operator or an application engineer, I can right mouse on this TradeFast login method, and from here I can launch a browser, I can download packets to a CSV file, or I can leverage SteelCentral's Packet Analyzer Plus to dive into the actual packets themselves to understand what's going on, and even bring up Transaction Analyzer to test the script out after I finish fixing this download issue. And from the same view, I can look at web applications, user groups, server IPs, even a geomap right down the line, different browsers. So we'll, like I said, a wealth of information from one view at your fingertips. Now I could go on for some time showing additional use cases, but I just wanted to show you some of the power AppResponse provides. So back to you, Alfred.
Thank you all for your presentations. Now we're going to go into our Q&A portion of the webinar. We do have a question for Riverbed. It says, what are you hearing about public cloud adoption from your customers? Alfred,
I can
would you
take
like
that. Yeah.
Great.
So the general pattern of answers I hear are public cloud adoption is a must-have for most of the customers we talk to. In fact, I think a good number of them have, in fact, several legs of production services deployed in the cloud. The interesting things that come up is when we ask about the variety of adoption, and our initial assumption, at least my initial assumption, was that our customers are going to pick one of the two or three big public cloud offerings that are out there. But it turns out our customers are not doing that. They're in fact, in some way, sort of hedging their bets, and they do have some services, for example, deployed in Azure because they find that environment more conducive to a certain type of application. And they have other services, for example, deployed in AWS. So the fact that we couldn't expect our customers to stick with one public cloud vendor was an important finding for us. So overall, yes, adoption is happening. It's real. It's here. It's been coming for a few years. But the adoption also is broader than just one vendor. So our customers are in fact spreading their usage around.
Next question is for Bala. Do you have a solution for monitoring other public clouds like Azure?
Yes, that's a great question. And there is a lot of interest with multiple clouds. So as Alfred mentioned, there are some customers who are looking at Azure. So we have collaborated with Microsoft, and recently Microsoft announced their VNet APIs, and we have done some basic level of integration, and we have early solution for Microsoft Azure monitoring, but it is something which is in our roadmap in terms of productizing it. That's where we stand.
Great. There's another question for you, Bala. How is Big Switch public cloud tap story better than the other leading vendors offering virtual taps, packet brokers in the public cloud?
I would say that it's really the integrated story that we have with Big Monitoring Fabric, which is a much superior solution. So we, as I talked about, how our public cloud monitoring solution is very consistent with the on-prem monitoring approach, and then having that single pane of glass and having a single instance, right, monitoring instance, which can monitor multiple VPCs and multiple instances. That is a real differentiator. So having that single pane of glass, where you can define policies for any monitoring or any VPC or any instance in the production cloud, AWS cloud. So that to me is a key differentiator. Jagdish, do you want to add anything to it?
Yeah, not only that, we also provide you, the customers with a central location where they can consolidate their tools. So it's a cost saving, and also we have visibility into the entire customer account. So those are the benefits of our solution. Yeah.
Perfect. We have a question, Alfred. I think this one should be for you. What type of performance or scale are your customers asking you to deliver?
Yeah, it's a good one. It's a fairly common one. Our initial conversations tend to point to starting scale of a gigabit per second or less. But when we actually map out what the customer's plans are for adoption, that quickly climbs, and it's very quickly goes to a few gigabits per second, something like 5 gigabits per second. That is real time, on time, all the time, from across anywhere from 100 compute servers virtualized to could be 500 or 5,000. The profile varies. At the very top end of the scale, I think in a couple of years, we are looking at the same kind of scale that we support on our physical appliances. So tens of gigabits is not too far off in the horizon in terms of what we're seeing based on customers are saying. The adoption is climbing very quickly.
We're running kind of short on time, so I'm going to wrap it up. And just want to remind you that if something here piques your interest or you'd like to know more, just head on over to bigswitch.com or riverbed.com. You can also email us at info@bigswitch.com. We make it really easy for you to get started with our solutions. We have several resources you can download, or you can watch videos that give you a tour of both of our products. In your handouts, you'll find live links in some of the handouts that we've shared with you. And one of the things we like to say is CSN Labs is something that we feel is a great way to experience Big Switch Network's cloud-first networking solutions firsthand from the comfort of your PC. It's a test drive, so it's a great way to try the product out and see how it works within your own environment. For a real free online access to our products, visit labs.bigswitch.com or download the handout. There's a link in the handout as well. I want to invite you to join us for our next webinar on Wednesday, March 20th with Radware. Watch your emails for an invitation to register or visit us at bigswitch.com/webinars. That concludes our presentation for today. We want to thank you for coming and have a great rest of your day.